Hello and welcome. Today's video lecture will focus on utility and optimal consumption. Let's understand this concept through a problem. The problem states, a consumer has a utility function such that U equals 8 times X times Y. Graph 5 possible combinations of X and Y that give a total utility of 160. So here we have the original equation, U equals 8 times X times Y. In this problem, we are told that total utility equals 160. Therefore, we could set U in this original equation to 160. When we do so, we could algebraically simplify by dividing by 8 on both sides. When we do so, our new equation is 20 equals X times Y. Once we have our simplified equation, we could find combinations of U that equal to 20. So in this chart, we have combinations of X and Y that multiply to be equal to 20. Here are some examples. The next part of the problem requires us to graph the combinations of X and Y that we have found previously. So as we see, when we plot the combinations of X and Y, a convex indifference curve appears. Let's continue on to part B. Part B asks, find the equations of marginal utility for X and Y. As a reminder, the marginal utility of X is a derivative of utility with respect to X, and the marginal utility of Y is a derivative of utility with respect to Y. Let's start with finding MUX. So we have the original utility equation here. When we find the derivative with respect to X, we look at the variable X. Currently it has an exponent of 1. According to the exponent rule, we subtract 1 and leave Y alone. When we subtract 1, we bring that 1 to the front multiplied by 8 as seen here, and this simplifies to 8y. We do the same thing to find the marginal utility of y. We start with the original equation and take the derivative with respect to y. Y has an exponent of 1, which is multiplied by 8 according to the product rule, and then subtracted by 1 according to the exponent rule. Therefore, the marginal utility of y is 8x. Part C asks the following question. What is the ratio of marginal utilities at the optimal consumption point? Currently, we don't know what the price of X is or what the price of Y is, but we do know what the ratio will be at equilibrium because the following statement is true. At equilibrium, the ratio of marginal utilities must equal the ratio of prices. So the answer to this question is the ratio of prices. Lastly, we have Part D. Part D asks, what is the optimal consumption point if the consumer spends $60 and if X costs 4 and Y costs 2? Remember, the equation to find utility maximization is this. The ratio of marginal utilities must equal the ratio of prices. Earlier, we calculated the marginal utility of X and the marginal utility of Y. We found them to be 8Y and 8X. Therefore, we can fill in the left side of this equation. We are also given the prices in this problem. The price of X is 4 and the price of Y is 2. So we can now fill in the right side of the equation. So let's simplify. 8y over 8x simplifies to y over x. And we know that p of x over p of y, 4 over 2, simplifies to 2. So our simplified optimum equation is y over x equals to 2. Once we have reached this point, we need to bring in another equation to solve this problem. We need an equation that ties together the consumer's monthly spending, the price of X, the quantity of X, the price of Y, and the quantity of Y. And the equation we have is this. M equals P of X times X plus P of Y times Y. This equation summarizes how much X and Y we could buy at the current prices given our monthly spending allotment. Given this equation, we could substitute what we know. We solved y to be equal to 2x, so let's plug in 2x at every position of y. So here we substitute y with 2x. Further simplifying, we could plug in the prices. We know p of x, the price of x is 4, p of y, the price of y is 2, and we already substituted y for 2x. Now we do some more algebra. Simplified here, 2 times 2x is 4x, and we have a simple one variable problem. 60 equals 8x. Solving for x, we get x to be 7.5. The optimal consumption of x for the consumer in this instance is 7.5 units. Given this, we can now solve for y by plugging 7.5 into x in this position. When we do so, we get y is equal to 15. So therefore, the optimal consumption for this individual is 7.5 units of x and 15 units of y. And that is it for this video tutorial. Thank you for watching.